This is Yan Chen. In this video series, I will show you how to do the batch refinement of diffraction pattern using GSUS and VDRIVE. This is the second video. In the previous video, I already showed you how to prepare a GSUS template file in the GSUS. And with the template file, we can use VDRIVE to do the batch refinement. So we have to follow these steps to do the batch refinement. First, we need to determine the parameters to refine and modify the template file accordingly. Then we save and rename this file. The name is very strict. We need to follow this format. The first number should be the raw number of the template file, and the second number, this 1, it should be the bank number, for example, the bank1 and .exp. We copy the template file into the working folder and then use VDRIVE to run this command. Now I just give you the demonstration. So in this analysis cluster, this is the template file we did last time. Now let me open it. You use ASP GUI. So this is chip_1, the file. This is already done, the refinement is done, but we need to modify the parameters a little bit to do the batch refinement. First, we can increase the number of cycles a little bit. This default value is 3, we can change it, for example, to 8. And for the phases, we'll refine the parameters and also this U, this atomic displacement parameter. This value will change as the temperature changes. We also refine the background, scaling factor, and also wave fraction. And for the profile, it's okay for the first phase, the BCC phase, but for the FCC phase, because it's going to decrease, it transform to BCC. So as the volume is going less, and also the intensity should be very low, we cannot refine so many parameters. So we just decrease these two. We only allow this sigma 1, this Gaussian broadening. And the same for the texture model, we also keep refining this BCC phase, but for the FCC phase, because it's decreasing, here we just assume the texture structure will not change. We just keep it the same. So we don't refine this one, just leave it as it is. And then we save as. Remember the format I mentioned. We need to use the raw number is the first row, so it's 1, and the underscore. This is the bank 1, so the other number is also 1, so it's 1_1.exp. We save it. Okay, we can close it. So this template file is here, and then we need to copy it to the working folder. And for this chapter runs is under the shared bind data and the chapter run number. If it's not chapter run and the working folder is only the bind underscore data, we don't have the chapter number. So let me paste it here. Okay, so this is a template. And then we'll go to the VDRIVE. Open the terminal, type IDL, and then add VDRIVE beta. So the command is like that. Let me go back to here. So its command is GSUS, and we specify which IPTS you are do. This chop run, the chop run number, and also we give it a range to refine, which is the start and which runs the end. And this is a template number, run number. It should be the same as here, the file number, and which bank we want to refine. This number should be also the same as this one. And then the last thing, we need to specify how many phases in this JSON file. This is chip still, we have 2 phases, so it should be 2 here. Okay, then let's type this number, GSUS IPTS it should be swap run. Here we just demonstrate from the first round to the 22nd. This template 1 is 1, bank also equals 1, and the phase number equals 2. And then we press enter. And then it starts to refine. It will take a while. Okay, we click this OK. Okay, a lot of files pump out. Let's go to this PDF first. It just shows a snapshot of the refinement. We just quickly go through it. It looks all okay. The residuals are almost flat. Okay, so yeah, here we can see that the BCC phase is decreasing. Our FCC phase is decreasing here. Okay, and then we'll have this summary file. We have two kinds of file. One is called it profile, so it's phase fraction, and the other one is the atom. So it's about the information of the atom. If you have, for example, the atom position change, or also the U is the atomic displacement parameter change. It shows here. So the information we are interested in is in this profile. So this the structure of the summary is like that. The first column is a round number, and those are the neutral informations, including sample environment. For example, if we do the low-free information, low-free experiment, we will have the stress strain information, and this is the temperature information. This is what we are interested in. If we move forward, we'll see here is the information of the phase 1. Here _1 means the phase 1. We'll have this is the wave fraction, and also this is the lattice parameter. Yeah, and so on. If you keep going, you have the information from the phase 2. The _2 is the phase 2. Okay, so let's try to plot. For example, if we want to see the temperature dependence of the wave fraction, the temperature, and also the wave fraction here. This is a wave fraction. Okay, so we can see that the phase transformation, the onset proposed here, and then quickly transformed. This is the BCC, FCC transformed to BCC. That's why it increased to almost 1. And if we plot the temperature versus the lattice parameter, yeah, we can see that it's almost linear, but slightly bent during the phase transformation, and it may also include the process of the element diffusion between the phases. This is the BCC phase. If we look at the FCC phase, it will be more significant. If we go to the phase 2, is the FCC phase, we plot the lattice parameter. Yeah, okay. Yeah, we can see this nonlinear behavior of that. So all these files can be found under this working folder, this PDF file, and those are the results of the refinement. And you may also find it in the folder outside. If you go to this shared folder, we have the GSAS results here. Double click, yeah, we will see the PDF and also this results. Okay, so thank you for watching this demonstration.